Alex Pault, editor-at-large for electronic design. And today we're going to talk about analog and digital integration at the chip level, which is not the easiest thing in the world to do, which is why we've got our friend here, Chris Morrison, Director of Product Marketing at Agile Analog, because they've got an interesting solution that we'll get to eventually. But first, Chris, welcome to the show. I'm glad you had an opportunity to talk to us.
Thanks, Alex. It's great to be here.
Well, you know, when you think about digital and analog integration, that's something that we've been struggling with ever since digital information actually became part of our livelihood infrastructure, as it were. You know, from the very first binary calculating devices, the ability to take analog information and make it digital and vice versa has always been a critical space, hasn't it?
Yeah, absolutely. I mean, the world is analog, and we want to sample that and to get it in the digital domain. And I think if you look at the moment, there's a huge explosion in areas like automotive, self-driving, where there's a huge need for more and more sensors to feed data into the system. In AI, getting that data to generate responses to, a lot of it is coming from analog sources. And even things like your watch or your headphones, there's lots and lots of areas where we're seeing an increase in the need for analog. And that goes even right down to areas where you don't normally think you'd need analog. For example, if you take server chips and some of the hyperscaler guys, the processes are getting so leading edge that you need to add analog sensors and even to monitor what's going on inside the chip itself.
Well, you know, that's an interesting aspect too, when you think about the issues of sensor integration and coordinating that information, and then reapplying that information in the analog world as well. You know, it is a very complicated situation. I mean, there are a lot of solutions that are out there. What are your thoughts on the current state of the art?
Yeah, I think it's interesting. I think the state of the art is going in two directions. We're seeing more and more integration in terms of the IoT space. So people are, because of space and power and cost, there's a real move to integrate more and more into your typical SoC, the consumer-based SoC. So I think that's one trend we're seeing, and that's probably accelerated from the component shortages we had a year or two ago, that people are wanting to have to source less components in their designs as well. And then like a second wave is in the other end at the very advanced nodes, where there's maybe some of the analog is being de-integrated and moved into chiplets side of things. So I think they're the two major trends that we're seeing in terms of analog at the moment. Integration at one end of the market and some de-integration at the other end.
Well, you know, it's interesting you mentioned chiplets, because a scalable modular approach is both being explored at the hardware side with the chiplets, but also on the software side with, you know, these activities like RISC-V, where you've got the community now, people are just uploading IP cores left and right.
Yeah, and actually, we're going to come on to talk about our subsystems in a little while, but one of the big motivators for us to do this was there's been a real explosion in people creating their own ICs thanks to RISC-V. I guess it's almost the revival of the ASIC from 30 years ago. And yeah, these guys are either very experienced in digital or are actually just taking something they've had in an FPGA and moving it into an IC. And as they've done the first generation, they're finding they need analog to interact with the outside world. And I think they're moving from just purely digital chips to chips that are mixed signal, and they just don't have the experience and knowledge, and they're looking around saying, how on earth do we get this into our chip and get it working? I think the traditional world of analog IP hasn't really been great for that. We've maybe sometimes given a block of analog IP and said, you guys work out how to get that in your system. What we're doing at Agile Analog is trying to ease that process making sure that the customer can easily integrate what they get and they know it's going to work without needing to put a lot of analog or mixed signal resource on it, which I think, as everyone knows, is a tough job role to fill at the moment, given the shortages of skilled engineers in the industry.
Well, that's an excellent point, Chris. What would you say are the primary challenges in integrating analog IP into a digital system?
So at the very outset, I mentioned the people getting the right skill set of both design engineers and verification engineers, and the right tools to support it, which are typically expensive. The EDA tools to properly do the mixed signal verification. But there's specific areas, and they're not going to be unfamiliar to a digital designer, but they need specialist care when you're looking at mixed signal in terms of boundaries, clock boundaries, bus boundaries, reset boundaries, really checking for metastability issues that are going on in your system. And that's an area where people tend to be left when they integrate a bit of analog IP to fix these issues themselves, and we're trying to solve that by wrapping some of the analog up in digital to take care of that difficult boundary between the analog and the digital, where you've got all sorts of asynchronous clocks and asynchronous data working from one domain to the other.
Well, that's an interesting term you use, that you're calling it digitally wrapped. It evokes almost a mental image of code being wrapped around these blocks. What made you think of it that way?
I mean, it's very much from the domain of code wrapping things around. When you look in the past, people have had to go to multiple different vendors to get multiple bits of analog IP, and they've all had to be integrated individually. And we wrap all of that in digital, and by wrapping it in digital, we give a single register map for all of your analog. We deal with all of the mixed signal verification. And we give the customer a system Verilog model that they can plug into their digital verification environment. And so it's literally, we are digitally wrapping the analog. You don't have to think about analog. You can think in a digital mindset. You can integrate it as a digital engineer, a digital verification flow, and it removes the analog that I think some people often find analog scary. Now, some of our analog engineers probably find digital scary, but at the moment there's a lot more digital engineers than analog engineers out there, and analog kind of looks like magic to them sometimes. So by wrapping this up, we're trying to reduce the pain in integrating analog, and also because we know our analog IP really well. It's been designed in-house here. We're the best people to do this mixed signal boundary, because we know what signals are coming. We know what domains they're in terms of power and clocks, and therefore we can integrate it well and just present a digital output or input to the customer.
Well, it's all about making it easy for the customer, right? And when you think about that, how much assistance does your average customer need to integrate your solution into theirs? Is it pretty much self-evident once they get the digitally wrapped packages, or do you need to help them optimize it?
So we work very closely with our customers. I think another area where we differentiate ourselves is that our analog IP is customizable. So upfront we talk to the customer about their exact requirements. So if they need a 12-bit ADC on a 12 nanometer process, then we can provide them the exact ADC they need with the exact specification they have on their exact PDK. And upfront we agree all of that. And then we work with them right the way through the design process. They have access to our engineers. We validate just before tape out. We strongly recommend they sit down with us and do a pre-tape out checklist and work our way through it. And we don't want to be in a position where we're just handing something and leaving it to the customer to know it's going to work. But this digital wrapping simplifies that process dramatically, because a lot of the things that we have to check when we just deliver IP, when we deliver it as a digitally wrapped subsystem, we don't have to check it because we've done that already in advance.
Got it. Got it. Now, I noticed in the release it mentions a few examples of these blocks, one for power, one for sensors. Why don't you describe a couple of them for us?
Yeah, so we've got a roadmap to roll out a lot of these subsystems going forward, but we're starting with 3 that we're really, based on market feedback, what we're really seeing people are needing. The first one of these is a power management unit. So that's providing the regulators, the power on reset, brownout detection that's required for a lot of systems. So that's our first one, Agile PMU. Then we've got the Agile PVT, which is PVT sensing. So that's monitoring the process voltage and temperature inside the die. So we have the actual sensors inside the die. This is used a lot in the advanced process nodes to monitor what's going on, to allow the device either to run faster because there's headroom, or to scale back how fast it's running to avoid the IC failing. And the final one of these is connected somewhat to the power management. It's our sleep management unit, and that is monitoring the wake up and the shutdown of the chip. So it's an always on IP that needs to be running all of the time to check for external inputs or an RTC trigger. In fact, we provide the RTC. And one of the big advantages that actually doing these subsystems has is by taking multiple bits of IP and integrating it together, you get the advantages we've talked about already from a digital perspective, but there's also advantages in the analog world. Having individual bits of IP, you sometimes over-design the things like output drivers that talk to other blocks of IP because you don't know where they're going to be next to each other, whether they'll be next to each other or across the chip from each other in a final design. And by building subsystems like this, we can scale these appropriately. And that's one example that leads to reduced area and reduced power consumption, which is probably the 2 main things we're always asked from by our customers.
Got it. Well, that was really comprehensive. Now, you mentioned that you're starting with these and you're moving forward. What's over the horizon? What's coming up next from these packages?
We're going to be announcing there a RISC-V subsystem, which will have all of the analog required for a RISC-V IoT project. So you can go and buy or develop your own digital core, and you can take our analog and integrate it. So that's the next step: bigger subsystems, more functionality, and building on top of our existing foundations of IP that we have available today.
Thank you so much. I really appreciate you taking the time to come on the show. Do you have any final thoughts for our audience before we let you go, though?
Yeah, thanks, Alex. It's been great being on the show today and chatting to you. I guess my final thought here is just looking at the analog that's required. And I think we'd love you to come and talk to Agile Analog, but one of the areas I think there's often overlooked is companies spend a lot of time developing foundational IP that doesn't add value in their systems. And there's a lot of IP companies out there, us being one of them, that can provide you with that foundational IP, allowing you to spend your time developing in areas where you can really differentiate. So yeah, I'd encourage you to check us out. By all means, check out the competition as well. And I think we can, together, we can innovate faster if we work together rather than everyone working in their own silo.
I agree with you completely on that. The more we work together, the better off we are. And I think the current trends in collaborative development tools and the like are really pushing people in that direction. So thank you. I really appreciate you taking the time, Chris. And I know our audience appreciates it as well.